So hello everyone, in this video we will discuss a very important topic of probability, that is the axiomatic approach to probability. Till now, whatever we have discussed, actually the probability, we have not learned how to find the probability. We have only learned about the simple space and some basic important definitions. Now we are going to learn how to find the probability. So for that we have some axioms and some rules, right? So that rules we will apply in the probability. Here we can also we will use the set theory portions also in this case. So see, what is the axiomatic approach? Axiomatic approach means axiom. You know, in the class 9 there was one chapter, Euclid geometry. In that we have discussed about the axioms and postulates, right? So axioms are those things that we supposed to be true, right? That proof not needed. That is the axiom. So that is the axiomatic approach, the similar one. So let us see. Let us suppose is we have a simple space for any random experiment, right? So we are doing any experiment and we are getting the output. Total output is called as the sample space if we write in the form of a set. So probability P, right? So probability P is what? A real value function, right? Whose domain is the power set of S and the range will be in the interval of 0 to 1. So this is important point. P, if you are writing, so P is the real value, probability is always a real value and it will be always between 0 to 1. So probability cannot be greater than 1 and it cannot be less than 0. So probability value is always lying between what? 0 to 1. That's very important point. This is 0 to 1. Both are including, means it can be 0, it can be 1. If it is 0, this is known as what? Impossible event, impossible event, and if it is 1, it's called as the sure event. It's called what? Sure event, right? So if probability is 1, sure event. If it is 0, it is impossible event, right? So let's find the following axioms. So if this type of situation, so first is what situation here. So for any events E, probability will be always greater than equal to 0. This is a very important point. We should note that probability cannot be less than 0. Probability maximum the sample space is 1. So if you are taking the total sample space, so probability is always 1. In sum of probability, if I are taking the sum of probability of all the, you can take the events, it is always 1. If I take the sum of probability of all the events, right, that is or you can say simply the probability of total sample space is always what? 1. So if E and F are two mutually exclusive event, right, so their probability will be like that. So see here, this point here we can explain it in this way also. Let us suppose here we have a sample space, right, and in this we have two events, events A. Let us suppose here it is events supposed to be B. This is B. This is, let us suppose to be A. This is B. So, or I think here we have taken E and F now, so it's more easy if I take E and F. Let us suppose this is your A and this is your F. Okay. So fine. What is here? E intersection F. Of course, it is 5. So as you have learned in the set theory, what is the N? If I ask what is N of E union F, so this is nothing but NE, right, plus NF, okay, minus N of E intersection F. If you want to find the probability, so probability is nothing but dividing the sample. If you, let us suppose if you want to find the probability of any event E, so what is the total number of event favorable to E divided by total sample space, or total number of element in the sample space? That is the definitions of your probability. So if you divide this whole things with the sample space to get the probability, so how to get the probability? So if you divide it here with the sample space, that is N of E union F with the sample space that is supposed to be Ns. Here also N of E divided by Ns, plus here also N of F divided by Ns. Here also minus N of E intersection F divided by Ns. So because of here it is 0, because there is 5 for the this set X mutually exclusive, you can say, or you can say the disjoint set. Likewise here, this will going to be 0. So you are getting what? N E union F divided by Ns is nothing but probability of this. So you can convert in the form of P. Probability of E union F is equal to Ne upon Ns is what? Probability of event E plus Nf upon Ns is probability of event F. So that is the formula here. Also it is given that probability of E union F is nothing but PE plus PF. So this is the formula we will use, very much important. Right. Next one here we have, you can see this point also, that if probability is 0, that is what? Probability 0 means impossible event, right? So it means F is 5 actually, there is no element there. So this is what actually, you can say the E and F are your disjoint set, right? So E and F is what actually? E and F, it is written, so E and F, here E and F will be what? Disjoint set, because there is no common, then only E intersection F is 5, okay? So this case also you can say, if you are finding E union 5, so you will get the same, because of probability of 5 0, if there is no element in the 5, because 5 having the 0 number of element, that will be 0 only. 0 upon Ns becomes 0, okay? So PE is equal to PE here, P equal to PE. So that things also we can note from here, that probability of any events with the empty set is the same as PE, because P5 will be 0 only. Now let us suppose, if I suppose that these are the following events, omega 1, omega 2 up to omega n. So events, if I write all the sample point here, so it will be what? Sample space, okay? So this is the things also. And if you are finding the probability of any individual events, so it will be always lie between 0 to 1, because you know probability cannot be greater than 1. So yes, probability of any events, so for all events belongs to our sample space, it will be always 0 to 1 only. Similarly, if you add the probability of all the sample point, so it will be always 1. So probability of omega 1, let us suppose here we have the sample space, and these are the sample point, omega 1, omega 2, omega 3 up to omega n. And individually, if you are finding the probability of omega 1 sample point plus probability of omega 2 sample point plus dot 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 plus probability of all omega n sample point, and if you are adding, so you will always get 1. So if you are finding the probability of all the individual sample point in the sample space, and if you are adding them, so you will get the 1. That is the second one. This one here, probability of any event will be what actually? So probability of all the individual sample point. So that is the here this third exams we will use, right? So these are the things here. Hopefully it's clear to you. So we will use in the questions this formula. Fine. Okay. So next here we have the probability of the equally likely outcomes, right? So what is the equally likely outcomes? See, let's first understand, whenever you are tossing a coin, right? So whenever you are tossing a coin, so outcomes may be your head or it may be tail. Outcomes may be your head or it may be tail. Head or tail, right? It may be head or it may be tail. So you can see this is actually equally, the equal chance that it may be head or equal chance that it may be tail. So this is called equally likely, means there is no favor to anyone. Let us suppose you are throwing a dice. So 1, 2, 3, 4, 5 and 6. So all are the equally likely. There is not favor that 1 can come more and 3 can come less, or 6 is coming more times. So this is not actually equally likely. If everyone having the equal chances to come, that is called as the equally likely, right? So here we have taken the examples that, let us suppose we have the sample space, and sample space, these are the sample point W1, W2 up to Wn, or whatever you can say omega. So W1 to Wn are our sample point, and here these all are the equally likely. So you can write W1, W2, W3 up to Wn are said to be equally likely, said to be equally likely, likely if 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 chances of their occurrence, if the chances of their occurrence is same or equal. So if their chances of occurrence is same or equal, then we will say yes, these are the equally likely, right? So if you find the individual probability, if someone asks, whenever tossing a coin, let us suppose examples, whenever tossing a coin, so whenever tossing a coin, what is the probability that head come, or what is the probability that tail come? So both are equal, half, right? Similarly, let us suppose we are taking example that tossing a dice. Let us suppose we are taking tossing a die. Okay, so whenever you are throwing a dice or tossing a dice, so throwing a die. So what is the outcomes? 1, 2, 3, 4, 5 or 6. So what is the probability that outcomes is 1? So it having only one favor, total 6, so 1 upon 6. What is the probability that outcomes is 2? Again 1 by 6, because here is only 1, 2. Probability of outcomes is 3, again 1 by 6. Probability that outcomes is 4, again 1 by 6, right? Probability that outcomes is 5, again 1 by 6. Probability that outcomes is 6, again 1 by 6. So all having the probability 1 by 6, 1 by 6. So what it means, if the outcomes are equally likely, their probability will be same. So in the theory here it is saying the same. Let us suppose you are finding the probability of any your sample point, and it is saying to, let us suppose to be p. So value of probability is always greater than equal to 0, but it will always be less than equal to 1. So if you add the all, if you are putting the sigma, means probability of all W1 plus probability of W2 plus probability of W3. So this is actually what? This is always 1, because if you are adding, if you can check here also, 1 by 6 plus 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 1 by 6 is always 1, right or not? If you are adding this all, 1 by 6 plus 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 1 by 6, you will get 1. Probability of 1, what is this actually? Probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. So probability of all the sample point will always be 1, right? Similarly here, let us suppose talking about the coin. So probability of head plus probability of tail is always equal to 1. Same case here, probability of all the outcomes will be always 1, and if we are considering the probability is p, so this is p plus p plus p up to n times. So what is actually this? This is n into p. So n into p is equal to your 1, right? So this is the case also here, that you must note. Okay, fine. So see, this is the formula we can use for the equally likely outcomes. Let us suppose here you are doing any experiment, and total number of possible outcomes is, this is your ns, right? And this is your favorable outcomes is ne, means what is in your favor. So this is the formula. So total number of favorable outcomes to e divided by total number of possible outcomes is called what? Actually is called your probability of e. The important formula for the, this we will use if all are equally likely. Okay, let us suppose take one example here for better understanding, that find the probability that outcomes is even number when throwing a dice, right? When we are throwing a dice. Okay, so when we are throwing a dice, then outcomes we want what? We want outcomes is our even number. So what is the meaning of that actually? See, first of all, we have to write the total sample space. So what is the sample space in this case? 1, 2, 3, 4, 5 and 6. So how many elements are there in the sample space? ns is equal to your 6. Now see, what is e? E is the our event for which we are talking about. So outcomes, we want that outcomes is even number, right? So outcomes is even number means outcomes is either 2 or 4 or 6. This is in our favor. Means what is the NE? Means number of those outcomes which is in the favor of E. How many? 1, 2, 3. So 3 are there. So what is the probability? So probability of your event E is actually what? So probability of your event E is nothing but this is your NE, means number of outcomes that is in the favor of E divided by NS, means total number of possible outcomes. So how many outcomes in the favor of E? That is 3 and total is 6. So what is the probability? Probability is half here in this case. So hopefully you get the concept of these examples, how we have to use this formula P. Fine. Okay, so next one is the probability of the events A or B. Okay, so fine, let's see how we can find this one. So here we can use, in this case, A or B means union actually have to find. Okay, so here A union B we have to find out. So this is A union B. Very simple. Let us suppose this is our sample, a space here, and in this case we have two events, events A and events B. Okay, this is simple space. This is what? This is the common region in all, means in both the events. So what is this actually? A intersection B, right? So first of all, let us suppose if we're talking about n of A union B. What is the A of n of A union B? That you know from the set, that is nothing but your NA plus NB minus n of A intersection B. This is a formula that we know from the set. Okay, fine. So what is the point actually? Dividing our favorable outcomes with the NS. What is NS actually? Total number of elements in the sample space, right? So total number of element, you can say number of elements in sample space. Okay, so if you divide here this all things with your ns, so you are getting here n of A union B divided by ns is equal to n of A divided by ns. Here also n of B divided by ns minus n of A intersection B divided by ns. So what is the meaning of this? This is nothing but probability of A union B. Okay, is equal to probability of A plus probability of set B minus probability of A intersection B. So what is the meaning of here minus? You can check this, because whenever you are writing PA, so this is already counted in your PA, right? If you are writing the PA probability, see this is your A, let us suppose, and this is your B here. So whenever you are writing PA means you have find out the probability of this region. Okay, but whenever you are finding PB means you are finding the probability of this region. So see, actually this shaded region is already once included in your PA, but once again it get included in the PB because you are adding a PB also. So this region has included two times. That's why we are here subtracting once the probability of this region A intersection B, right? See here the political questions or all the sets question also can be done in, let us suppose here if you have two sets, right? So we can do in this way. We have to distinguish all the region here. Let us suppose this is A and B. So you can suppose in this way, this is one type of region, this is your second type of region, this is your third type of region, this is your fourth type of region. So total 4 region we have divided, and accordingly you can find. See, actually what we want here, we want the probability of this region. Actually what do you want? You want A union B. See, this is the second method I am showing here, method number 2. So here actually you want what? Probability of A union B. Means you want addition of 1 plus 2 plus 3 region. Okay. Okay, with the help of this formula actually, if you can see, so if you are adding, let us suppose PA, right? If you are writing here PA plus PB, okay, So what is this actually? You can see if you are doing PA, what is the PA actually? So PA is nothing but your 1 plus 2. Okay, and when you are writing here PB, so in PB also what? 2 plus 3. You can see clearly this 2 actually added 2 times. Okay, so actually you want here 1 plus 2 plus 3 only, means you have to subtract this 2 ones. That's why they are subtracting ones, and that is 2 is nothing but your what? Probability of A intersection B. That's why it is coming. So 1 is cancelled and you are getting your required value. So hopefully you get the concept of these things. Now we can solve the exercise question. So in the next coming video, I will show you the exercise question. Okay. So thank you so much. We meet in the next video. Thank you.